Okay, today we are going to look at inverses. Sorry I could not be here today, but this video will help you get through the link sheets to look at inverses with multiple representations. So the first thing you want to do is copy down the four functions from problem 6-5 onto your four link sheets and put them right here in the function box. We're going to do p of x together. So as you can see, p of x is 2 times quantity of x plus 3 quantity cubed. There are two ways to find the equation of an inverse. The first way is the word way. And in the word way, you write down what the original function does. So if I were to put a number in for x, the first thing I would do to that x is I would add 3. After I added that 3, I would then cube it, and then I would multiply by 2. Just like when we played the Guess My Number game yesterday, we did the opposite operation, worked backwards. The inverse, or the undo function, does the same thing. So therefore, we start at the bottom and do the opposite operation. So the first thing we would do is divide by 2. Then we would undo the cube, which means we would take the cube root. And finally, we'd undo the adding 3 by subtracting 3. We then need to write our equation. So we denote the inverse by using the p to the negative 1. That's denoted by the inverse of p. And then I usually just write an x. And then the first thing we did was divide it by 2. So that's why we have x over 2. Then we took the cube root of it. That's why that x over 2 is the cube root of that. And then we subtract 3. Note, the cube root has the x and then division by 2 underneath it, and the minus 3 is outside the cube root because the minus 3 is what we do last. So that's the inverse equation. The other way that we can find inverse equations is the algebraic way. So for this example, I do want you to write down both ways, but when you do the examples on your own, you can choose either the word way or the algebraic way. So when we do the algebraic way, first thing you want to do is change the f of x or the p of x to y. In this case, it would be p of x. Then you're going to switch our x and y, because if you remember from yesterday, we looked at the tables and the x and y values were switched. And then we solve for y using our order of operations backwards. So following along, here's our p of x equation. We're going to change p of x to y. Going to switch x and y, and then do my PEMDAS backwards to solve for y. So first thing I'm going to do is divide by 2. And then I have to get rid of that exponent of 3, so I take the cube root of both sides. And then finally, I would have to subtract 3. And that would leave me with p inverse of x, the p to the negative 1 of x, equals the cube root of x over 2 minus 3. Same equation, two different ways we got it. Okay, after we find the equation, which we did both ways, you only have to do one way on your own, we're going to make the table. So we're going to go to our graphing calculators and type in p of x for y1, and p inverse of x for y2. And you should see your graphs look exactly like mine do. If you remember, here's our original p of x. It shifted 3 units to the left. So that means when we look at our table, we should kind of have -3 centered around, x value of -3 centered around our points, our table. And we also only want to be able to plug in equations that, or use whole number or integer values for y, and also use values that we can actually plot on the graph provided. So although -16 and +16 are not going to fit, it's going to give us a nice shape of how our graph is going to look. So we're going to use the x values between -5 and -1. And as you can see, they would be right here, or you can also get them from your graphing calculator. And then when we look at our inverse, our y2's, notice there's a lot of decimals here, and we want to be able to graph whole numbers or integer values. So we're going to try and find integer y value first. So at -16, I have an integer y value of -5. So that's the first point I'm going to use, -16, -5. And then I'm going to scroll down to try and find another integer value for y2. And the next one I see is -2, -4. And I see 0, -3. 2, -2. Those are, again, another integer value for y. And then I'm going to try and find one more integer value for y2. And at 16, -1 is the y. So that gives me, that is the table. Alright, so pause the video, take some time, graph both of the inverse and the original p of x function. Alright, welcome back. Hopefully your graph should look something like I have. And so our original p of x looks like this, and the green's the inverse. So you can see, although we didn't actually graph the -16 and +16s didn't fit, it gave us an idea of how the graphs are going to be shaped. So for yours, when you do them on your own, just graph what fits. So the graph you have there. Finally, we want to kind of sum all this up. Find the relationships between an original function and its inverse or undo function. And first off, for the equation, whatever the original does, the inverse undoes. So the inverse undoes the original function. A way that we can check that is to pick any number to put in the inverse. Usually a nice small number works well. So let's just say I'm going to do p of 2. And if I put 2 into my p function, I'd have to add 3 to the 2 first and get 5. 5 cubed will be 125. And then I'd multiply 125 by 2 to get 250. If I then put that number into the inverse, so I'm going to say p inverse of 250, I would then have to take the 250, divide it by 2 and get 125, take the cube root of 125, which is 5, and subtract 3, which is 2. So if you notice, we started out with a 2, the original function did something, the inverse undid whatever the original function did, and we ended up with what we started with, a 2. If two functions are inverses, that will always happen. Next on the table, if you look at our table, we see that the x and y values are switched. Here, in the original, we had -5, -16. In the inverse, we had -16, -5. In the original, we had -4, -2. In the inverse, we had -2, -4. The x and y values will always be switched for inverses. And finally, if you look at the graph, there is actually a line of symmetry on that graph. it is not a vertical or horizontal line, it is actually the diagonal line right here. And notice the slope is up 1 over 1 and the y-intercept is 0. So the equation of that line of symmetry, LOS, is y equals x. And again, the graph will have a line of symmetry at y equals x. These will always be true for all inverses. So just check these when you do these on your own, and the only thing you have to do is do the check with the numbers. Alright, try the other 3 on your own. Hopefully you do well, and we'll answer any questions tomorrow.